Thanks for hosting. Thanks, Gepatek, for hosting and providing the venue. Yes, my talk is about 1 year building a package manager for Kubernetes. And a little question in the room. Who of you has either created an open source project and maintains it actively or like regularly contributes to one? Okay, cool. I see a few hands.
I also made a commentary recently.
Oh, nice.
To chicken PhD.
Chicken. Okay. So I think we'll go over the story of how we created the open source project and what we learned after the journey of 1 year. I'm going to start with a little introduction. For everyone who doesn't know me, my name is Philip. I'm one of the co-founders of Glasskube, the company behind the open source project. I have a traditional background studying computer science at the Vienna University of Technology. And after that, I was the CTO of an alerting company for firefighter organizations and also enterprise emergency alerting. We started the Glasskube journey 2 years ago out of the interest in dev tooling and open source projects. But before we go deeper into the Kubernetes and deployment space, I want to give you a little history about Helm. It's like the de facto package manager. I think everybody in the room knows Helm and used it. Yes, perfect. Little history, which actually was interesting to me. Helm was created 2015, so nearly like exactly 10 years ago by a company called Diese Labs from a hackathon. It was like Matt Butcher, awesome guy, created it in a hackathon. It had like an alcohol theme, and then he came back to his boss and said, "Oh yeah, we created this super new package manager. It's about beer and bottling." And then his boss said, let's keep the project, but like let's go with another theme. So he looked up like an article dictionary, and he came up with like Helm as like steering. In 2016, there was another project like from the Google guys called the Kubernetes Deployment Manager. These projects actually merged, and Helm 2.0 was created with a server-side component. So in the early days, like Helm 2 had a server-side component. You could create the charts. It had a central repository, and yeah, it was then created. A new release was created in 2018, Helm 3.0, removing all these server-side components and creating a client-side tool only. They claimed because of security reasons and not being able to control all the custom resources. But in fact, when Helm was created 2015, there was no concept of custom resources. There was no concept of all the modern APIs there are nowadays in the Kubernetes cluster. All of these haven't existed back then. But Helm is still growing. It now supports since 2022 OCI images. And I was recently at the kickoff for the Helm 4 development at the KubeCon in Salt Lake City. And we discussed what Helm 4 should look like and what changes should be incorporated. And it has now a community lead by big enterprises, like I think from SUSE and Red Hat, and both said like anonymously, we don't want to break Helm. We don't want to make any major changes, which is on the one hand good for all the existing clusters out there, but also a little bit pity because they will not be able to address major problems or flaws which are currently in there. But when we first wrote our Helm chart, we didn't know any of this. We assumed Helm is this technology which is like super complicated to write Helm charts with, right? When the first time with our first product, we created a Helm chart, we thought, wow, this is so complicated. All this Go templating. Then we want to do like dependencies across multiple namespaces. It did not work. Like Helm charts fail all the time. They got stuck in some weird states. And we said, you know what? I'm going to write blog post about the pitfalls of Helm and just put it out in the world and release it on Hacker News. And it actually got 133 upvotes on Hacker News and a huge amount of discussion. So you cannot read it. I can share the link. You can back then, but it was like 180 people on the internet complaining about Helm and saying, yeah, it's like it has so many downsides. Somebody needs to change it. And so we thought, okay, wait a minute. We are working on like an app marketplace for a cloud provider which generated revenue and was actually a fun thing to do. But on the other hand, we have like so many people complaining about Helm as a technology, which seems to be like as a huge potential. We said as a company, okay, I think we're gonna go all in on the package manager case and really try to build a package manager that suits us and all the people out there complaining about Helm as a technology. And you know what could go wrong, right? The application developers worked in the DevOps field, have like experience in running Kubernetes clusters, used Helm a lot. And yeah, I mean, there has been some challenges, right? The whole team has never written any Go code. So it was like, this might be tricky. And we also didn't have any internal knowledge about Helm or the Helm history. We didn't talk with like the contributors or the original authors of Helm. And we also have no real experience in running 60, 70, 80 node, huge multi-tenant, high secure on-premise Kubernetes clusters. I think we are super confident in running this mid to low clusters on cloud providers, but we don't have like this huge enterprise expertise. But back then, we took a look, okay, Kube Builder looks easy. We can generate some custom resources, custom Kubernetes APIs. We should be able to do it. Another assumption, a lot of people complained about like the missing GUI. And we also couldn't wrap our head around why Argo CD was superior to Flux. And the only reason for us why it could have made sense is that Argo CD provides some kind of GUI. And so we thought, yeah, Glasskube as a package manager also needs to have a GUI to work. And then we thought, okay, this central package repository, we can make it work. We really can think we can make it work if we get the dependencies right. So it was like exactly little over 1 year ago. We stuck our heads together, did the first MVP in 6 months, supported really only a limited amount of packages, and only one type of packages, cluster scope packages. So you couldn't, the custom resource definition was like cluster scoped, or custom resource was cluster scoped, and we couldn't install like multiple packages in one namespace, for example, or multiple packages in different namespaces. All of this we wasn't able to do, and we also had no package configurations. So, but more or less, what could go wrong? We just put the first release out there, and actually it was really a success. So we said, nice, we did it. In the end, we have been like trending on GitHub. We got a lot of people using it, trying it out, giving us feedback, and quickly grew a community. And people talked about it, joined our Discord, and we actually also empowered the community. And I think for everyone like wanting to create and release a project, it's super important to initially empower the community and create some buzz. So if you really want to put a project out there, make sure you have some good first issues, have like a contributing guideline, organize community calls, and bring all these contributors together in order to create more buzz around you. And this will then eventually also make your project more popular. At least more people will like try it out, check it out, and it will appear on the section on GitHub if you're trending. Oh, you're working on repositories with the hashtag Kubernetes. Look at the package manager. And this actually worked out. A lot of people got to know us, people made videos about it, and we got some initial traction, which is really, really good. But the reason we built the package manager in the first place was our internal problem of shipping application to our clusters, because like we didn't want to write custom huge Helm charts. And let's go a little bit into the features we developed over the first year, right? So in order, how does the perfect CI/CD, and I'm also really curious for your talk later, the perfect CI/CD flow look like, right? Because we have like multiple clusters, multiple GitOps repositories, and we really only want to test a package once, preferably in a CI/CD environment, right? This should then get auto-merged if everything goes green, and then we have like Renovate, an awesome tool which should like distribute the application across our infra repos about our clusters, yada yada yada. And we can use and leverage our own UI to quickly access our own dashboard, see which packages are installed, outdated. We can open them like a shortcut for kube control port forward to a service, and have all this flow in our CI/CD. So the first thing we wrote is like a scout, and we thought, okay, how can we detect new package versions? because renovate matches not only do not work all the time, so we really created our own CLI, because after I think a couple of months only writing Go code, I thought, yeah, let's do something else in JavaScript or TypeScript again. So we used like the Oak-Cliff. It's like an open source CLI framework. Oak-Cliff, open source CLI framework. Yes, it's from Salesforce. And yeah, having worked with Cobra before and now with Oak-Cliff, for the next CLI, I'll choose Cobra again and go the Go route. I think it's like TypeScript or JavaScript doesn't get close to the performance you could get with Cobra, and it's just feel a little bit clunky. But yeah, you could scout packages. You can create our index from our public package repository, and you can also check if the new package version's out there. So this is the first step. We constantly run in our public package repositories our scout that scouts for new packages out there, either releases, artifact hub changes, or we support basically everything. Second thing is, as soon as our scout detected a new package update out there, we create the pull request in our public package repository, and a CI/CD GitHub action. As our repository is public, we can make unlimited actions, which is super nice and free. In every CI/CD, we start a Minikube cluster, install a new package update, do also some metrics compatibility checks, updates, yada yada yada. And if the package update was green in our CI/CD Minikube cluster, we can hopefully then auto-merge it into a public package repository, and making sure that if something is in our package repository, it actually works. And then we integrate it into Renovate. I think most of you know Renovate, right? And I think the beauty about these kind of open source projects is you can integrate them. And really kudos to the guys at Renovate. Their contribution experience is really, really great. They have been, I don't know, reviewing pull requests in a couple of hours most of the time. And also we got a little bit inspired from their release flow, like they use the merge queues. They enforce always like a squash and merge on a pull request to not pollute the Git history, but really have like a clear commit message enforcing like semantic commits on the conventional commits on the pull request titles, and a lot of good stuff. So if you're looking for a boilerplate open source project and contributing guidelines, you can definitely look at the Renovate repository. It's really, really good. And they also auto-generate all the documentation, which led us to Renovate natively supporting Glasskube packages. So as soon as you have a Glasskube package in your GitOps repository, infrastructure as code, Renovate will then go against our public repository and create a pull request, for example, Kubernetes stack, major update, and we can auto-merge it completely because we already knew all the packages that Renovate finds are tested in our CI/CD. And as soon as a package goes into the cluster, either via the UI or the CLI we created, or like via like GitOps tools like Flux, Argo, which directly create the custom resource, our package controller then reconciles the package, checks if there are any dependencies. If the dependencies, the package controller will then say, okay, I need some more package infos, and we have like a dependency tree with a SAT solver, so a dependency like similar to. Okay. And yes, like SAT solver, looking if the dependencies can be reconciled, and we're gonna fetch all the dependencies in the Kubernetes cluster as a custom resource, build everything up, deploy everything, and then report the status back either to the custom resource status section, or you can see it like in real time in the client and in the CLI. So adoption. I think this is after 1 year. It's super interesting that obviously Glasskube is an awesome technology. It works. We use it in our cluster. We see a lot of companies using it, but I think this is also like tricky. Creating open sources are out there. You don't exactly know who is using you and what are they using you for, because we have a super open license. We have Apache 2 license, so everyone in the world can use our code and completely rename it, build up topics. They should give us a notice, but in reality, we don't know. We see that Glasskube from some limited metrics we have is like installed in all major cloud providers. So we installed in some clusters with more than 30 nodes. We actually got contacted by large enterprise corporates saying, yeah, super nice, I have my 5G, some telco company 5G stack I want to deploy to my telco providers. And we're looking exactly like a deployment model as you do. We have some more questions, but when we're gonna adopt it, we're gonna basically use everything ourselves. We're gonna get our own package repository, but we're gonna basically fork it and do it yourself, which is really, really cool. But it's like hard to get these like super corporate enterprises then contribute back to your repositories. One of the second like adoption we saw is that package subscriptions happen. A lot of like corporates or companies come to us and say, yeah, I really like your package manager, make it really easy to install, for example, RabbitMQ, operate some kind of like clusters or applications, but then they say, yeah, I'm still not really confident with all the day two operations, although it should be, it is just a Glasskube update, and we also just do Glasskube updates or install the renovate integration. They really want to have this kind of assurance that they have somebody they can trust and talk to if something happens, or they just want to get like hand-holded in their Kubernetes cluster with their packages if they adopt like a technology like Glasskube, which also works. But are we as popular as Helm? I guess no. Because like 1 year really trying to build a better alternative to Helm, we also realized that, and this also brings me to the learnings, that Kubernetes is not a greenfield technology anymore. With a lot of customers or DevOps engineers we talk to, we always see some kind of deployment process, Kubernetes cluster is already out there, because obviously, yeah, because if you talk to DevOps engineers at conferences, their DevOps engineers get hired working in Kubernetes cluster, and therefore they often have to like do a lot of like housekeeping stuff and are not able to migrate into a whole new package infrastructure. And I think this is also related to a lot of different open source projects. If you should think about if your open source project is easily pluggable into like an existing ecosystem, a CI/CD pipeline, or if you're really a replace all solution. And in our case, we're really more the replace all solution. So for a lot of like new green Kubernetes clusters, greenfield projects, we see people coming and say, hey, we want to have like a clean package approach, install everything with Glasskube, and then all the dependencies up to this cert manager makes really, really sense. And also for us, doing open source project as a company is a great way to establish some kind of thought leadership, go to conferences, talk with a lot of people. I think we really dug down super deep into all the dependency, Helm, deployment issues you can encounter. And a lot of like companies and corporates then come us to the founders and say, yeah, super interesting, but we're actually looking for a deployment solution, but all of our clients just using VMs and Kubernetes is in play. Can you do something? Can you help us there? And this is one of the best learnings, that open source technologies and projects are really a great way to interact with a community, get to talks with people, and potentially build some business or new projects together. And I think what we also learned, that contributors are often not the same kind of people than users. A lot of people, we encountered this, like found our project, found it super interesting, played around with it and wanted to contribute because they wanted to dig deeper into the Kubernetes ecosystem. They wanted to contribute to a project on the CNCF landscape. They wanted to improve their own coding skills. And we really also built a lot of features for these kind of people who are super enthusiastic contributors. But it's also important to, like, if you want to have like more commercial adoption, to more focus on commercial, I mean, in hindsight it's obvious, but to focus more on like commercial features, commercial adoption, and not so much on, I would say, individual features for your home labs. Like Glasskube is used like the most amount of installations are in one node clusters, which is super cool, but we're used so much in super small home labs and like local testing environments where people just want to have their cert manager, their Postgres installed without any like fire and forget. And we focus a lot on these kind of use cases, not knowingly directly that this will hard to build their corporate relationships or like finding some sponsors, because as a successful open source project, and then also gets accepted into CNCF, a project should not be only on one corporate shoulders, right? A project should be contributed by multiple big corporates, and therefore you need to have like a different feature sets. But open source developer tooling is super fun, and it's we will build and launch the next tool, because with Helm I think we realized that Helm is a technology used to more like a zip tool. You can bundle up your manifests, have some limited templating, and ship it over the fence. Because if you're like an application, independent software vendor, an ISV, and you want to give your customers your application, you don't want to give them any dependencies or tooling or opinions on how to deploy it. You just want to give them the bare manifest, what is minimum needed to get it installed. And yeah, this is why Helm is really, really great. And I think we couldn't replace Helm, but I think we created a cool tool that lives like besides Helm. And I think the space is big enough for a lot of package managers. And I think we are focusing for now on making sure that our existing customers for Glasskube are well served, are happy, and are launching the next big tool actually tomorrow. So yeah, we are still loving the developer tooling. And yeah, I think these are the main learnings from building a package manager, right? Focus on, be loud in the beginning, focus on your users, but don't mistake your contributors for your users. And yeah, I think as long as some corporates are happy with us, it's definitely a success. But building like a licensing or business model around and completely open source software, and not with like professional services or anything else, can be super tricky. But yeah, thank you.